Hello, everybody. Can you hear me? If you could maybe comment in the chat if the sound is coming through okay. This is Ruth from Fermentis speaking.
I can.
Loud and clear. Great. Well, firstly, welcome, everybody. Thank you so much for popping online and joining us in this webinar. Today, we're doing a sour beer workshop, and I know there's people joining us from right across the Asia Pacific region, so it's really awesome, and I can see a great variety of people we have participating in the chat as well, which is great. Just move on and do some introductions. Firstly, I would love to introduce my colleague Simon, who had to set a very early alarm this morning. Simon is in Belgium, so it's 6 a.m. for him, and he is our technical sales support manager for Fermentis in Asia Pacific. So Simon actually has a role where he links between R&D and transfers all of the latest knowledge to the rest of our team in Asia Pacific. So Simon was actually born in Belgium, but he's not usually based there, but because of the coronavirus situation, that's where he is right now. He fell in love with beer in his family kitchen, then studied chemical engineering and went on then to do some research at SAB Miller in South Africa, and then worked throughout Central Europe and throughout Asia in the field of biotechnology for beer production. So very well placed to speak to us today. And I'll let him introduce his beer and then me.
Yeah, thank you, Ruth. And of course, you can see the label of my favorite beer at the moment, which is called Berliner Weiss. And the Berliner is actually surroundings where I'm from in Belgium, in south of Belgium. So this beer is brewed by a friend. This is a Berliner Weiss type of beer. And he's using lactobacillus for the souring and then USO5 for fermentation. And it's very refreshing to have sour beers in the fridge at the moment because we are lucky. We have quite a good weather in Belgium. And of course, I will now introduce my colleague Ruth. So Ruth is Regional Technical Sales Manager for ANZ JCO. So this includes Australia, New Zealand, Japan, and Korea. She started her working life as a yeast propagator at Lion Brewery in New Zealand. And while there, she also studied her IBD diploma in brewing. She grew up to love beer as a postgrad student, studying fermentation science at Otago University. And since then, Ruth has had different jobs, working with breweries, supplying specialty ingredients, prior to her role at Fermentis now. So thanks, Ruth, for being here, and I give you the mic.
Okay, so I'll just introduce my favorite sour beer at the moment. I think it changes all the time when I taste a new one, but I just tried the beer on the screen you can see this week from the Wild Workshop of Garage Project in New Zealand, and it's a lovely, fruity, juicy, hazy, but nicely balanced sour beer with guava, coconut, and lime. So really delicious and refreshing. Okay, so I think a lot of you are quickly working out how to use the webinar functions, but when you're a participant, you are able to chat. We will aim for having approximately 60 minutes of content, so 1 hour today, and then we will spend time doing questions and answers at the end. So we'll have about 30 minutes of Q&A time. If you would like to ask a verbal question, please let us know in the chat and we can come down and unmute you. We will have some brewers speaking later on in the piece about some of their experiences as well. And if we don't get to your question, please follow up afterwards with us at the APAC Fermentis email address. We will be sending out the PDF copy of these slides to everybody with the email address that you registered with. So no need to try and take notes. You will get a copy of these slides. Okay. So this is the agenda that we will go through today, a really quick history of sours, and then talk all about topics to do with sours like pH, acidity, the different microbes that are relevant, techniques, things to look out for, problems you can have. We'll talk a little bit about yeast choice for the fermentation as well, and then the different styles of sours too. We'll then talk about some evaluation we did on kettle sours, and then follow up with some key takeaways and some tips on some of the more important topics when you're making a sour beer. And then we'll quickly dive into Australia and Vietnam for a market snapshot and talk with some brewers about some trials, and then end with a Q&A. And I was supposed to do a poll right at the beginning, and I'm going to do it right now. So I hope you will see on your screen. Can somebody let me know in the chat that you can see a poll? We're just asking, what type of brewing are you involved in? Are you a home brewer? Are you a craft brewer? Are you working at a large scale brewery? Or are you just interested in brewing in sour beer? Like me, I guess. Yep, you can see it, cool. Yay, I can see a lot of votes coming in. I'll try and present these results in a moment. Okay, can you all see that? It's about 60% of you are from craft breweries, and then a mixture of people interested, large scale and home brewing as well. Okay, back to the webinar. Now I'm going to actually just to define what we're talking about too, because sour is quite a broad topic, and actually sour beer, it's more of a descriptive than a specific style, and there's many styles within sour itself. So today we're talking about any beer that's been intentionally brewed to have some sourness and tartness, and usually from the lactic acid forming bacteria. So we're not going to talk specifically about adding lactic acid itself, and that being your only method to make a sour. So it incorporates a big range of styles. And
happy to see that we have a lot of brewers with us today. So happy to help you to discover a little bit more about the sour side. And of course, the first step is a little bit of history. And as Ruth just said, sour beer is a beer that is intentionally produced to be sour. But back in those old times, in 1,000 years ago, where the sour style started to be to spread around the world, the sour beers were just made from spontaneous fermentation. They were also aged in barrels without cooling system to be able to control this fermentation temperature, and also no ability and no access to fresh yeast, where nowadays you can actually select the single strain you would like to inoculate in your wort. And so because of that, the beers were spoiled, and that was leading to sour beer. And the origin of the first sours is known to be in Germany and Belgium. So we'll discover a lot more about sour in the following slides. And what is important also to know, one of the basic concepts of a sour beer is the acidity, of course. But this acidity can be coming from a lot of different acids. For example, in your daily life, in the food and in the beverages, if you drink Coke, there is a sourness. There is a sourness in this Coke coming from phosphoric acid. If you also bite in a slice of lemon, this is also something sour, and it's coming from the citric acid that you have in this fruit. If you look at vinegar, this is coming from acetic acid. If you look at green apple, this is also coming from an acid, which is the malic acid. So in the food and beverages, lots of different acids coming either from the food or coming also from microorganisms helping to get these acids. And another concept that is very important to understand is the pH, because as you know, pH is related to the sourness, the acidity that you have in a beer or in a beverage. And here's just a range of a few common drinks and their related pH. So you can see milk is actually an acidic drink because it's slightly below 7 of pH. Then you've got coffee at 4.5, ales and lagers. And of course, what is what interests us today is the sour beer with a pH of 3 and 3.4. But of course, it's you as a brewer who also has the choice to go either lower or higher than that. And when you think about pH and when you think about acidity, it's actually two different measures, because when you measure pH, you actually have an expression of the concentration of disassociated hydrogen ion into the solution. Whereas if you talk about total acidity, there you have an expression in gram per liters of all undissociated but also dissociated acid compounds in the solution. It means that it's a different measure, and the pH gives no indication on the total mass of acid that you have in the solution, only on the hydrogen. And rate that you have in the solution. So it is a measure that is more accurate to the real acidity that you have in a beer, in a sour beer, for instance. Then, if we keep going into the basics of sour beer, of course, you cannot have any acidity, you cannot have any pH dropping if you don't have a good microbes to help you doing this by producing acids. So on the left side, we've got the microbes that you can find in sour beer, which are the Saccharomyces cerevisiae that you know very well already for the production of alcohol, esters, CO2. Then you've got the Brettanomyces, which are also common strain that are found in sour beers. Brettanomyces tends to produce funky flavor, also acetic acid. And then on the right, we've got the different bacteria that you can find in sour beers. So the first ones, Lactobacillus, Pediococcus, and Eunococcus, are called lactic acid bacteria because they produce mainly lactic acid. And then there is also some beers where you can find Acetobacter, and this particular bacteria produces acetic acid. And the last strain that we have in our Fermentis range is actually Lactobacillus plantarum, and we will talk a little bit later more about it in this presentation. So if you're curious to know how it looks like, these microorganisms that you can find in your sour beer. So on the left, you've got the yeast, again, with the Saccharomyces that you know very well, then the Brettanomyces, and on the right, we've got the world of bacteria with the Pediococcus looking like small eggs, then the Lactobacillus, and Eunococcus uni. And what is also more interesting about these microbes and these microorganisms is, of course, what kind of flavors they will be producing. So if you look at the yeast flavors, as I already introduced, the Saccharomyces, you know already very well. It helps you to produce complex flavors from the esters, higher alcohol. You can also have some phenolic flavor if your strain is puff positive. Then on the Brettanomyces, this is a very funky word because you can have, in one hand, from the Brettanomyces, fruity notes of apple, pineapple, tropical fruits. But also on the other hand, depending on the dosage, depending on the strain, you can also have a very funky flavor and brings complexity into your beer. And the word funky has for definition as a flavor horse sweat, earthy, cheesy, horse blanket. So typically farm flavors, if you would like to say. And then on the right, we've got the bacteria word and the bacteria flavors. So for the Pediococcus, you would get bright lemony tart character coming from the lactic acid. But the Pediococcus, on the other hand, also produces diacetyl. And then in the Lactobacillus word, we have also, but also depending on the strains, you can have some nice tropical notes, fruity notes, and of course the dairy-like character from the lactic acid. And then talking about Eunococcus uni, it is a strain that is tolerant to alcohol and low pH, and it produces also lactic acid and diacetyl. So now that you know all the basics, all the tools that you need for producing a sour, there is also different souring techniques. And one of the oldest souring techniques is actually the picture that you can see here, which is the coolship fermenter, well, at least the start of fermentation. The coolship that is in Cantillon Brewery in Belgium to produce the lambic. So what you see is actually the wort that is just being poured into this big and open vessel, and it is actually on the top floor of the brewery. And they would just do it in the afternoon, and then overnight they would open all the windows around it to be able for the microorganisms that are naturally present inside in the air to be able to inoculate this wort before it goes into wood bearers for fermentation. And for the souring techniques, I hand it over to Ruth.
Thanks, Simon. Well, just like there's a variety of microbes you can use to make a sour beer, there's also many different techniques you can use to make a sour. First of all, I'll look at mash souring. That's one of the two methods you can do on the hot side of the process. So this is when you use a lactic acid bacteria like a lactobacillus or a pediococcus to sour the mash. And to do that, you can either inoculate a pure culture, or you can use the natural bacteria that is actually on the grains themselves. And you can either steep the grains in the mash vessel or maybe use some spent grain as well to then pitch in and sour the wort. There's a couple of things to think about and to be careful with sour mashing. You have a lot of natural microbes on grains. So some like Clostridium bacteria can cause some quite yucky off notes like butyric acid if they're able to grow. They don't need any oxygen. On the other side of the coin, you do have other bacteria like Acetobacter, which can create quite a vinegary taste. And a lot of effort is often made to remove the oxygen when you're mash souring to make sure that the Acetobacter can't grow. So people even putting, cling film or purging with CO2 in the vessel to remove the oxygen. The next technique on the hot side is kettle souring, very common and very efficient. We get a lot of feedback that brewers find this technique quite easy to control because you can control the temperature and the heat transfer very well when you've got a liquid as compared to a mash where there's some more solids. So you would usually pitch a pure culture or mixed cultures into the wort in the kettle at the correct temperature for it to then sour. And then once it's reached the desired acidity, you would boil like normal. Well, in some cases you may not boil. Usually you would. So it's a great option for clean flavor and tartness and a low risk of infection as well because you're doing it all in one vessel and then boiling afterwards. Some people even use yogurt actually to inoculate into the kettle, which can create quite an interesting profile. Another technique is actually doing some of the souring in barrels, a little bit like the beer example on the right. So they're not always just for adding some nice oak character to the beer, but you could have natural microbes in the barrels themselves from maybe prior batches of beer or whatever was in there before, or it could even be just some leftover acidity or fruit in the barrels as well. Or you can also choose to inoculate specific cultures for the barrel aging. Okay, we continue with the different techniques for souring. So souring in fermentation vessels, so doing a mixed culture inoculation with the fermentation yeasts as well as bacteria. So you might pitch in some lactobacillus and or Saccharomyces to do the actual alcoholic fermentation. Pediococcus is actually quite an interesting choice if you're doing this because it handles quite well alcohol and the iso-alpha acids from hops. But you do need to be very careful because there is a risk of contamination when you're in the fermenter with the bacteria. So yeah, super good cleaning techniques needed there. Spontaneous fermentation, Simon's already talked about that, and you saw the coolship from Cantillon. So it's, you know, any of the yeast and bacteria in the area come to the sugar party. It's usually done in the cool temperatures when you're more likely to get the desirable yeast and bacteria fermenting the wort. And you know, no two breweries have the exact same flora, so mixture of yeast and bacteria. So that's why their beers can taste quite different, and why it's very hard to try and move, you know, a very traditional spontaneous fermentation recipe from one brewery to another. And lastly, blending is a technique that can be used to make or to come to your final beer with sours. So blending different ingredients like fruit, but often different barrels and tanks of beer together, maybe one sour stream and one not soured stream together as well. So it just enables the brewers to really create and steer that flavor profile the right way. All right, there's a few things to watch out for when making sours. One is that hops are a very useful ingredient for flavor, aroma, and the fact that they do act as a natural preservative because they have that antimicrobial activity. But because of that, they can also harm some of those microbes that you want to do the souring. So we recommend that you sour the wort before you hop. In this case, if you're using something like a lactobacillus, around 5 IBUs can start to inhibit the growth. So do your souring and then hopping later if you're using lactobacillus, or just keep the hopping to a low level. Temperature. Each organism has its own ideal working range. You know, with Lactobacillus plantarum, it's often between 30 to 40 degrees. It quite likes temperatures around human body temperature. For our Cefsar product, it's 37 degrees. So you want to get that temperature right, so you're encouraging the microbes you want to be working very well to do their work. So always check the specification or the literature. Okay, and a couple of other things to be mindful of. If you're starting to use Brettanomyces, which is a very commonly found in some of the sour beer styles, it's a great yeast to create some really interesting flavors, and it's acid tolerant. But just be mindful that it does ferment those longer chain sugars like dextrins quite slowly over time. So you need to be careful of reaching either a higher than intended alcohol content with this yeast, and avoid packaging too early. So just make sure that you are finished the ferment, or you've monitored and tested that really carefully. A unique feature actually of Brettanomyces is that it does often form a pellicle. You can see a picture there on the top. There's actually a lot of expose the yeast to oxygen, but the main theory is that it's actually preserving that wort for the Brettanomyces and stopping other competing organisms getting in there. And the last thing I want to mention is alcohol percentage. So if you're doing a mixed fermentation at the same time with yeast and the bacteria, some strains are quite intolerant to alcohol. So for Lactobacillus, the range is usually between 3 to 9%. So keep it in mind, and Pediococcus could be a good option here because it can handle quite a high alcohol content. Okay, this slide is here really just to show you that is quite a wide range of sour styles. This is the Beer Judge Certification Program definition book. So there's a list of the European sour ales, and we'll talk specifically about some of these in a minute. Like Gueuze, for example. And then you've got your historical beers like the Gose, which is unique to the Gueuze, and it is salted. And Simon will also talk about that. Then you've got the American wild ales, so mixed fermentation sour beer, which quite a few that I see in my market would probably fall into this category, or a wild fermented specialty beer. And then if all else fails, there's also the experimental beer category if you're really wanting to be creative with your recipes. Okay,
so thank you, Ruth. So let's talk a little bit about a few recipes. So we have selected a few ones to describe today. So the first is a lambic souring. As you saw already, the cool ship. The big cool ship is the place where the inoculation occurs when you brew when the lambic is brewed. And so what is very interesting with the lambic souring is that there is a very, very complex, spontaneous, sequential fermentation. So a lot of different microbes are actually playing a role in the production of this beer, in the fermentation of this beer. And if you look at the first step, this is always bacteria and a yeast called Cloquera. For 2 or 3 weeks, this yeast and bacteria will be fermenting. Then you would have the Saccharomyces cerevisiae yeast performing the alcoholic fermentation for 3 to 4 months. And then you would have the lactic acid bacteria, mainly Pediococcus, providing lactic acid fermentation for another 4 to 5 months. And then it's only at the end, when all the simple sugars are consumed, then the Brettanomyces lambicus would come and finish the fermentation with the fermentation of the complex sugars that were left behind. And a few others key point of the lambic souring. You know already the spontaneous fermentation. Ruth already introduced the fact that the lambic producer are using old hops, aged hops. So they basically keep very old hops for up to 3 years, for a minimum of 3 years, sorry, because like this, there is almost no bitterness left, but there is still a slight bacteriostatic power to be able to control the different microorganisms that are able to develop. And also lambic use unmalted wheat for 30 up to 40%. And of course, you can also have different variation using fruits. You can also have lambic blending, and a gose is actually a blend of young lambic and old lambic. Then if we go to another very traditional style of sour, but this one is coming from Germany. This is the Gause. This particular recipe is known for his little bit of tart, salty character, and that makes it a very, very refreshing beer. And it's not very far away from the Berliner Weiss style of sour beer that you know already, because it also has low ABV, lots of wheat in the grist, and also low hopping and tart sourness. But the main difference and the biggest difference would be on the salty character. Then if you look at a few recipe tips, the malt bill is a blend of Pilsner and wheat malts. You have only a short boil. You only add the hops after boiling with a minimal addition of 15 IBUs. And then you also add on top of the salts, yes, also some coriander, which makes it very specific. And then still in Germany, another very interesting style is, of course, the Berliner Weiss. And so this is a style that has been called the Champagne of the North by Napoleon, because this type of beer has a higher attenuation, because it's actually using Brettanomyces and also lactic acid bacteria. So you have nice sourness coming from lactic acid and acetic acid, but also thanks to the fact that Brettanomyces have glucoamylase able to cut down the dextrin and then therefore ferment the complex sugars, you have also higher attenuation in this kind of beer. And the traditional way to produce Berliner Weiss was to use an unboiled and unhopped wort, and then the first fermentation was done with Brettanomyces and lactic acid bacteria, and then of course, to get a little bit of alcohol and carbonation in the bottle, it was blended with Krausen, Saccharomyces cerevisiae yeast, and then bottled for the second fermentation. But nowadays, the modern way of producing Berliner Weiss is to use kettle souring techniques with inoculation with lactobacillus strain, and then later fermentation with Saccharomyces cerevisiae. You could also do, alternatively, half wort fermented and then blend it with another wort to also choose the right sourness that you want in your beer. But of course, those are very traditional styles, a few of the very traditional styles. But nowadays, what is also very, very interesting in the beer world and also specifically in the sour world, as you could see, is that there is a lot of diversity, creativity, and experimentations. Ruth?
It's for me. Okay. On your screen, you can see a couple of examples. I put there from my home country of New Zealand. So we have a lovely sour from Deep Creek called Mahalo, which is a combination mash and kettle sour. So they, believe that those techniques give them the really good flavor profile they're after. And then for the Deep Creek, which actually won a top gold award last year at the Brewers Guild of New Zealand Awards, they use a combination of a primary ferment that includes Brettanomyces. Then they age in red wine barrels. Then they do a secondary fruit fermentation on tart cherries for a couple of months. And then the beer is bottle conditioned for a lovely carbonation as well. So, traditional or modern, that really is the brewer's choice. Okay, one question I get asked quite a lot is, what is the best Saccharomyces yeast for a mixed fermentation? What should I choose when I'm making my sours? So there's two ways you can really answer this. One is, can our yeast handle the pH of a sour? And we have tested our strains with kettle souring acidifications down to the very low pH 3, and we've seen no performance impact from our study and trials on that. And the second way to think about this is, what flavors are you looking for in your beer? So, and that is what we actually learn from brewers who trial it and give us feedback. We know from the market, for example, that, USO5 is a very popular ale strain and neutral. So it's quite suitable if you're adding a lot of fruit or spice, because that can then come through and shine through quite cleanly. If you want a little bit more fruity esters, then the English ale SO4 is a good choice. We have a fruity Belgian strain, BE256, and actually the beer example on the right-hand side there from Fork Brewing in New Zealand, that uses Cefsar BE256 to really enhance some of those fruity stone fruit and raspberry flavors in that beer. If you're making a lager, we know Cef Lager S189 is really nice, handles quite well in high temperature fermentations, and gives a nice stone fruit aroma. You've also got the Saison strain, a nice dry, that yeast will attenuate very highly and also give really good fruity and spicy clovey notes as well. And of course, you've got the German wheat strain if you're going that way. So again, it's really the brewer's choice, but we have tested that the yeasts can ferment very well at a very low pH, around 3, which is common. All right, so next section, we're going to talk a little bit more specifically about some trials that we've done on kettle souring to give you some advice, I guess, to take away if you're playing around with the kettle souring technique. So here's Simon.
Thank you. So here's a traditional beer process, and then if you look on the bottom of the picture, there is the kettle souring process. So basically, you start with regular mashing, regular lautering, but then you don't boil your wort. You boil your wort, sorry, but you cool it down to proper temperature for the lactic acid fermentation, which is in the range of 30 to 40 degrees. In the first boil, you don't add any hops for the reasons that we already mentioned earlier. But then after the lactic acid fermentation, you can definitely add some hops if you like, and do a regular boil before going through the regular steps also of the brewing process. So the kettle souring is just a few things to remember. You have a first boil for sanitation, but without addition of any hops. Then you cool down to a proper temperature for lactic acid fermentation. And then you have a second boil for the hop addition. And as I mentioned at the beginning of this presentation, Fermentis has studied different microorganisms, different lactic acid bacteria, and through different studies, we have selected a strain of lactobacillus, which is the Lactobacillus plantarum. And this strain of bacteria is a homofermentative strain. It means that it only produces, mainly produces lactic acid from the fermentation, and the flavors that it's developing is a balance of tropical notes, fruity notes, and of course a good freshness sensation that you get from the lactic acid production. And this bacteria is also easy to use, so it means you can just use it as it is when you open the packet. No risk of contamination in the surroundings of the brewery, and no need of hydration process. So what did we do? I said that we had a few studies about also this strain. So what we wanted to do is to take your place as a brewer and ask ourselves, okay, I have this strain of bacteria. I want to produce a sour. Then what will be the influence of different pitching rates, of different density, of different temperature, and of agitation on my fermentation kinetics, but also on the other hand on my flavors. And so we've done a lot of different experiments from a suspension of Cefsar, from a wort of Cefsar, and we had different parameters, different conditions, and here are the results. So first, the influence of pitching rate on acidification. Here so on the left you have the pH evolution over time in hours, and what you can see from the two different dosage of 10 gram per hectoliters and 100 gram of hectoliters is that pretty much after 24 hours, in any case, you have already an acidification which is almost complete. The only difference is that by increasing the dosage, as you can see on the curve, by increasing the dosage, you can actually lower a little bit the final pH that you will get during your Kettle Sour process. Then if we look at also the pitching rate influence, but here not on the pH, but specifically on the lactic acid production, you can definitely see that, of course, there is a difference between 10 gram per hectoliters and 100 gram per hectoliters. The higher will be the pitching rate, the higher will be the production of lactic acid in your beer. Then if we look at another interesting parameters, which is the temperature, we have here the influence of temperature on the pH over time. And so what you can definitely see is that if you look at the temperature of 45 and 50 degrees, which are the one at the top, you don't have a lot of fermentation, a lot of production of lactic acid. And that's because those temperatures are actually too high for the lactobacillus strain. So higher temperature, higher than 40, is not recommended at all if you want to use Kettle Sour process with lactobacillus. But 37 degrees, 40 degrees, and also low and lowering your pH. Then the temperature influence on this time the lactic acid production more specifically. So as I just said earlier, you can definitely see that at 45 C and 50 C, there is almost no production of lactic acid, just because you're killing your bacteria with too high temperature. You inhibit or kill the bacteria. But then if you look at the differences between 37 degrees Celsius and 40 degrees Celsius, you can actually control the level of lactic acid that you want in your sour beer. So if you use 40 degrees, you will start to inhibit a few of the bacteria, and you will have lower lactic acid production. But if you look at 37 degrees, this is the highest, and this is the best, the optimum temperature if you really want to have the highest lactic acid production. And then we also studied the wort density influence on the acidification. So here what you can see is that if you increase your density, there will be actually a slight increase of the pH because of the increased buffer effect of your wort. But if you look at the difference between 8 plateau and 12 plateau, in terms of pH, there is almost no difference in the end of the kettle souring process. But we can also look at the wort density influence on this time, the lactic acid production more specifically. And what you can see is that if you choose lower density, you will be able to have lower lactic acid production. But then if you increase your density at a certain point, if you go higher than 16 plateau, there will be just only a slight increase in lactic acid production. And then the last but not the least is the organoleptic profile. And so what we did is that we took two different dosage pitching rate of the Lactobacillus plantarum LP652. We inoculated it in a wort, and at Fermentis in headquarters in Europe, we have a panel of expert tasters. And we gave them those samples, and they've been able to describe the different flavors that they perceived with these two different dosage. So the one that the curve that you see in orange is the wort only, and then in blue, in dark blue and light blue, this is two different pitching rates of lactobacillus. And what you can definitely see, what you can obviously see, is that there is a decrease of sweetness, of course, decrease of honey, a decrease of cereal perception, decrease of the malty perception, and on the other hand, an increase of fruity flavors, an increase of dairy flavor, an increase of acidity and volatile acidity. And if you're curious to know about the exact descriptors that they've been able to choose for the fruity flavors, this is mainly tropical fruits and citrus. And now we will introduce you to a few key takeaways because we love to help you as a brewers. And we receive a lot of questions, and to help you in the production of your sour, here are a few commonly asked questions. So, Ruth, I could ask you, okay, I'm producing sour beer. I want to produce a sour beer. I want to use bacteria, Lactobacillus. But then, what kind of level of acidity should I target to have a beer that is liked and appreciated by my consumers?
Thank you, Simon. And just a quick note, if anyone, I saw one person watching saying the slide is not updating, maybe hit the refresh if something's happening there, but we will send them out afterwards as a reminder for you all as well. Okay, so what level of acidity for my consumers? It's an interesting question, and I've heard some, anecdotal feedback, for example, from Australian brewers that, if you go back some years, the pH and acidity was not as aggressive as it could be now, because consumers' palates do adjust to sour beer as well. But if you can see this rate beer screen cap here, you can see the consumer ratings and then the amount of lactic acid, so the grams per litre. And in general, that's the median range between 8 to 10 grams per litre that is thought by consumers as being quite balanced. And above 11, getting up to 17 grams per litre, quite a sour and heavy and too much acidity sometimes. But it's also, you've got to think about the beer as a whole as well. So it's that whole sugar acid balance. What else are you adding into the beer? If you're adding fruit, remember it will add sweetness, but also acidity. It might also be fermented. So all of these things are manipulating that sugar acid balance and affecting that acidity that your consumers will then taste. Okay, now Simon, I know you're the pH and total acidity expert. What one should I measure?
Yes, that's actually an interesting question that we get a lot, because as a brewer, what is very easy to use is, of course, a pH meter. But we know that measuring the pH is not always correlated to the acidity, the total acidity perception that you might have in your work. So if you have different hydrogen. But if you measure total acidity, then you have a very good and accurate image of the total acidity that you have in your beer. So if you want to analytically measure this acidity, it's actually better to be able to measure total acidity. So this is something you can do with an acid test, or if you do titration with a strong base like NaOH, you're able to measure this total acidity. And my advice for the brewers would be, of course, to maybe have the chance to do it once. If you're able to measure total acidity once, then you have this measure. And then if you take into account that you don't change anything in your recipe, you could measure also the pH. And this pH would be an easy measure, an accurate measure related to this total acidity. And then in later brews, you could just measure the pH, check your pH, and see if it has moved, to be able to know that you have the same acidity. And then, of course, the best detector of acidity would be also you, because you can just taste your beer, find yourself the right amount of acidity that you like, and just take note of the pH it's related to, and keep this pH in mind for later brews. And then Ruth, by using lactobacillus, by using Brettanomyces, by using any of those wild bacteria, wild yeast, what is the risk of cross-contamination that I might have in my brewing?
Well, I mean, I think the understanding is there that there is always quite a risk when you've got, even more than one microorganism in a brewery. And in fact, some very large scale breweries may have a completely separate facility for making sour beer because of that. Yes, there is a risk, but there's absolutely ways to manage the risk. So first of all, when you're actually first pitching in the bacteria, be careful. Some of them are quite dusty. And that's actually why we purposely designed the Cefsar a bit like our yeasts, in that it's easy to use so it doesn't dust, because the dust itself can then go and contaminate parts of your brewery and end up into other beers. So always ensure really good cleaning practices, and specifically if you're preparing starters and repitching, you need to be super careful of your hygiene. The kettle souring process, as we talked about before, is very safe. You get really good control and heat transfer there. And then you have the hot side boiling step. So you've then got a clean wort after that stage. So if you're using wild microorganisms, either in the primary or your secondary, pay really good attention to your cleaning practices. All right, Simon, if I'm using a lactobacillus, what about if I play around with the pitching rate? Do I get much benefit from changing it?
So actually, yeah, pitching rate is a very interesting tool and useful tool for you as a brewer to be able to pick up your final pH, to target your final pH. So in the previous slides, we saw two different dosages of 10 grams per hectoliters and 100 grams per hectoliters. But actually, in between, if you're picking up a different dosage, you can actually target different pH. And so basically, the higher will be the pitching rate, the lower would be the pH. And so if you want to really fine-tune your final pH, your acidity when using a lactobacillus, you have the pitching rate as a great tool, but you can also play with your density.
Okay, Simon, I've had a few sour beers that don't really have much head. How do I keep the foam, the nice head in my sour beers?
So yeah, if you think about lambic beer, of course, those beers are fermented with wild microorganisms, but also fermented in barrels. So in the barrels, the CO2 is not really kept into the beer, and you don't have a lot of foam with those beers. But nowadays, with the more modern styles of sour, you can actually play with mixed fermentation. And so by using also Saccharomyces cerevisiae yeast, you're able to produce a lot of CO2. And you can also bottle condition if you want to to keep the CO2 in your beer, in your sour beer. Another key point to have a nice foam is, of course, to use wheat malt, depending, of course, on your recipe. To use also flake barley. And then, more specifically, by using lactobacillus, what is inside a lactobacillus is an endogenous enzyme, which is protease. And this protease is actually able to cut down the foam active proteins that you have in your beer. And so when using lactobacillus, if you want to inhibit this particular enzymes, it is advised to lower your pH before the kettle sour process. And so all those advices will help you to keep good foam in sour beers.
Okay, we are going to have a little look around the world briefly, and I've just activated Sean Tommen, who is on the line from East West Brewery. Thank you so much, Sean. Hopefully everyone can see on the screen, same as me. Hello.
Hello.
Hi, everyone hearing Sean?
Simon? Yeah, all good.
Good. Okay, cool. So Sean's, I'm going to let Sean speak briefly about his experiment, his sour beer experiment.
Yeah. So last year we got a hold of the LP652. Thanks to Krishna and Joe. Shout out. And we got to experiment with this before it kind of went out in the market, and it was really fun. We did a collaboration with Heart of Darkness, another brewery here in Ho Chi Minh City. And we each did 2 different batches. We did 2 different parameters of souring. So we experimented with the dose rate and timing. We did one that was a little bit longer. We did 44 hours with a low dose rate of 10 grams per hectoliter in the souring. And then Heart of Darkness, I believe, did 24 hours with a pretty high dose rate. So it was kind of like 2 different speeds, and see if we got any character differences out of it. We really noticed that the souring was pretty much done at 24 hours anyway. So there really wasn't ultimately an angle at the 44 hours. I think you probably touched on this, Simon, that it's very speedy, the souring. Where normally we've done a lot of sours before with grain inoculation or the liquid pitches, yogurt and stuff like that. We've done pretty much everything, and a lot of that can range even upwards of 72 hours to sour. So to get this down within 24 hours is really nice and very clean. So we did a kind of a Berliner Weiss style, and we fruited it. So both Heart of Darkness and myself, we fruited with 2 different fruits as well, so we could see kind of what we're doing. We did a similar grain though, but we did different fruits and the different souring. We used a chai cop, which is Vietnamese for a June plum or Amberilla fruit. If you've heard of it, you can see the picture there. It's kind of a plum-ish fruit that grows here in Vietnam. It's very seasonal. They eat it on the street. When it is seasonal, it's really, really popular. It's eaten green or it's eaten ripe. We use the ripe one, the real sweet one, but it's also very tart itself. Kind of a mango, pineapple-y, plumish thing. It's really good. So we wanted to try it, and it worked out. It does have this kind of unusual vegetal note that kind of comes out as a green chili, almost jalapeno-like thing, and the sour actually intensified that flavor, which for some people I guess might be off-putting, but I found it really unusual and unique and good. So yeah, the sour went really well. We did this collaboration. We put both beers on at our tap room and served them separately. We also did like a 50-50 mix of the 2, and customers were really into it. It tasted really great. And we've been doing sours every month since. So it's been very popular. It was, you know, trial and error to see if Vietnamese would be into sours. It's kind of a new flavor, sour beer for them. And it's been hit and miss for some, but the people who really love it, really, really love it. So it's something that we've kept on pretty regularly. And now we do a different fruit, different sour style every month. episode.
Awesome. Thank you so much, Sean. And I did taste the beer and the blend of beer. We've now got Neil on the line too. So that's very cool. I'll flip to his side so you guys can see the other side of the collaboration as well. And Neil, if you've got any comments, please go ahead.
Hello. Can you hear me okay?
Yeah, good.
Awesome.
Fantastic. Well, thanks guys for the invite, both to the webinar and also, for getting us on board on the original collab project. We love to do our collabs here, and so it's great to work with Sean and East West. Obviously, the other part of this project was to trial out the new souring product, LP652, to ask what can we do with it, what's it going to give us, what can we use it for. So as a counterpoint to Sean's approach, we thought we would try out using a real big high dose of lacto and a relatively short souring time. And then just for fun, we wanted to see if we could use it in a high gravity brewing situation whereby we would perform one large mash, one big boil and souring before carrying out two smaller secondary boils. So for the final product, we were kind of looking to produce maybe about 120 liters. So we thought we would try souring 90 liters overnight, split that into 2 times 45, and then liquor them back for that final boil. The beer itself was a 3.5% peach-infused sour that, as Sean mentioned, would be blended with the offering from East West. Very interesting, enjoyed that. The grist, featuring malts from Castle, mainly pale, healthy dose of wheat in there to try and get that foam, the nice head. And then some sweeter malts just for body and colour. Marrying that with some Southern Hemisphere hops from New Zealand, Australia, and some peach also in the whirlpool of the secondary boil. Okay, so for the souring, because of our short incubation time and the liquor backs, as I mentioned, we wanted to do a high dose. So that went up to about 65 grams a litre, which is definitely on the upper end of your recommended amount. And we pitched that in at 37. And that's just something that we found was a sweet spot generally from our past experience. I know obviously different strains will behave differently, but that was also fed down from you guys. So that would be a nice place to work at. So 37 is what we maintained our souring at for about 22 hours, I think it was, in total. We didn't do any pre-acidification. The reason being we just wanted to see exactly what this bug would give us, just left to its own devices. And so what did it give us? Right, so yeah, so sorry, 37 degrees seemed a really good spot. The firing was super fast. That's judged by pH. That was our only metric for judging the souring. We were really happy with the sensory. It took our work from being sweet and malty to really nice and fruity with a quite intense acidity.
Cool.
Sorry. Some really interesting notes in there. I mean, to my nose, and this isn't specific to this product, but I can get a really intense tomato soup kind of flavor going on, and that's normally a good sign for me. It's not something that everyone else picks up. So there was a good level of acidity in there. No dairy. For certain styles, you might want a little bit of that, but in this particular beer, that's not something that we wanted, and so that was a good point for us. So we performed this liquor back, and afterwards we found that the pH was maintained, and actually it came through a little bit sharper, which is kind of interesting. But I'm guessing, the nature of the acids we're working with here, the weak acids or whatever, so you're going to maintain that pH, but the total acidity is going to be less, and the buffering characteristics are going to be affected by the liquor back there. But after boiling, we actually found that the secondary boil, we found that it all kind of came back in the mouth and everything tied together quite nicely. So So actually, we were really happy with the beer that came out, and especially when it was blended with Sean's effort. And so for us, the take homes was that it was a great product to use, really simple, gave us superb characteristics on the sensory front. If we were going to repeat this liquor back approach, it would be, generally speaking, and it would be really nice if we could expand our lab so that we could actually understand what was going on in terms of total acidity. So to mitigate against that, we might consider making a slightly higher gravity beer, or counter to what Sean was saying, we might consider looking at souring a little bit longer, perhaps. Yeah.
Great learnings. Thank you so much, both of you. Really appreciated that. Very cool. I'll just take you guys off the screen so you don't need to worry about background noise or colleagues. But thanks again, really interesting. It was good to have a look in Vietnam. We're going to have a quick look in Australia now, and I just wanted to share, I know we've got a few Australians on the line, but just, letting some of the other regions know what beers are actually doing really well and selling well and appealing to the consumers at the moment in Australia. So you can see here that a lot of fruit is being used. On the left-hand side of the screen, you can see a number of raspberry beers. So raspberry is a very popular fruit to pair with. Often it's a Berliner Weiss, sometimes it's a Kettle Sour Ale or a Goza. And in the middle section there, you've got a hoppy sour from Colonial, which is an interesting one, and then a whole range of other fruits being used. Grape and passion fruit and mango is a nice combination in the bent spoke. Also the Pash the Magic Dragon, which has dragon fruit. And then on the right-hand side, I guess sour beer in Australia is relatively evolved compared to some of the other Asia Pacific region. And you do have breweries like Wildflower doing some really interesting beers. This is a golden ale of theirs. It has a warm primary ferment with their house mixed culture. Dollar Bill, where this is actually aged on lees in wine barrels afterwards. So really complex and interesting beers. And up the top, the blobfish logo there, that's actually a festival that's specifically for sour beers that's held last year for the first time in Melbourne. And there was a lot of breweries there and a beautiful array of sour beers on offer. All right, so we are going to find next, we're going to find Ross from Rocky Ridge. Where is he? There we go. Just to have a little chat actually about some trials he did. Now, Ross will be coming online now. We were actually going to together talk about some beer at a conference over in Perth in March, but due to the coronavirus, that didn't actually happen. So, hey, Ross.
Hi.
How are you going? So
well,
good. Yeah, we can hear you.
Yeah, sorry for any background noise as well. Basically, I'm in the quietest spot in the brewery, but we're canning, transferring, and doing all sorts of stuff. So, yeah. So basically, we use the LP652 as well. We've done a fair range of different sours here. We have got a few mixed ferment projects going on. We do barrel ferments with mixed ferment as well. We've got a perpetual sour tank, which is basically whenever got a whole range. I think we started off with BE134 as the primary ferment yeast. We've then grown up bugs from whenever we get beers in, which we like the funk. We'll grow that up and pitch that in there as well. We've actually just pulled 12 barrels off of that, which we're co-fermenting again in barrel with plums and pears. So that should be pretty cool when it comes out. So yeah, so the one we're talking about is our Melancholy Sour. So it's a little Berliner Weiss. Basically, we use the Fermentis Souring method here. So we'll basically just do a 15-minute boil to kill any bugs that are in amongst the malt. It was probably about 75% Pils malt, 25% raw wheat. Knocked out and pitched at 38 degrees. We were about 12 grams per hectoliter pitching right with the South Sour. We've actually locked it up and left it over the weekend. It had dropped to 34 degrees Celsius when we came in on the Monday morning, and the pH was down at 3.1. Really nice, clean acid profile to it. Was already quite fruity. We then crashed that down to 21 degrees and dry hop with El Dorado, just to get about 5 IBUs there to knock out the lacto and to make it legally beer in Australia according to the ATO. And then after another 24 hours, we pitched US05. Generally, with doing the Fermentis Sour, I always pitch fresh bricks of yeast. There's not going to be a lot of oxygen left free in the wort at that stage, so I find I get a better sort of ferment profile that way. Got about 73% attenuation from that, and when we were about 60% of the way through, we cut up, minced, pureed, heated 1 ton of watermelons, and they then got pitched into the fermenter as well.
A lot, right? A lot of watermelon.
Yeah, that was a fun day for the assistant brewer.
Yeah, I bet. Very cool. Thank you so much, Ross. Really appreciate you taking a little break from a busy day by the sound of it.
No problem at all.
Yeah, thanks so much. Very cool. All right, thanks everybody for listening, and that concludes the main content of our webinar. We're going to go to Q&A in a second. I'm just going to do a really quick poll. I know we haven't done the Q&A yet, but imagine we have. So you might see on your screen now a poll, just your thoughts on the webinar. It's completely anonymous. Please give us your honest feedback. We'd really love to hear what you think. We're trying to, speak to quite a wide range of brewers, and we're happy to continue any discussions offline as well if we don't get time to speak to you during the Q&A. So thank you. I can see some people still voting, so I'll just leave it for a little second. Great. Okay. Thank you, guys. Very cool. Okay. All right. Can we see the slides again? Question and answers. Now, thank you so much. And I've seen a few more coming through while we've been talking as well. I'm going to bring some up on my screen. And please let us know in the chat if you want to ask some verbal questions. Let me see what we have got. So, Alistair Robbie, you asked some really good questions. Alistair's from Australia, asking about using aged hops. Simon, have you got any comments on that, looking more into the aged hops? So that's where they have their static properties still, but obviously the flavour changes and some other things change too.
In terms of flavors, when you want to use aged hops for the sour beer production, what you want is not the flavors from the hops because you aged them, you have a huge decrease in bitterness. So what you really aim for, what you really target, is only to keep a little bit of bacteriostatic power. So by using these aged hops, you don't bring bitterness and flavors, but you can actually help your wild yeast, your wild microbes, to develop better than unwanted ones. So talking about aged hops, there's different methods to do it. You can age your hops in a bag. You can age your hops in a vessel up to 3 years. It's not really. I don't think it's a very complex process. It's just about oxidizing your hops from the atmosphere, from the oxygen. So pretty straightforward.
Awesome. And Alistair was asking also about auto-termination of, I guess, Cefsar or Lactobacillus plantarum in general. And we do know, obviously, hops are, going to kill, but also high levels of alcohol. Simon, have you got anything to add to that? It was at a particular pH, or will it just keep on going? Will it auto-terminate, so die?
So yeah, if you remember the studies that we've done, if you remember the density, the influence of the density on the lactic acid production. So at a certain point, your lactic acid bacteria will just raise kind of kind of a limit in lactic acid production, and this lactic acid production is of course related to a pH, to an acidification. So at a certain point, we haven't gone up to upper level of density, upper than 16 so far, and yet. But what we noticed between between 12 and 16 is that there is not much difference in terms of lactic acid production. So I would believe, yes, there is of course a kind of a natural limitation in the pH that you would get, and it's in the range of 3.2 from our studies and different experiments. This is the limit of pH you would get with the Lactobacillus plantarum.
Yeah, thank you. And we had a few questions around the pH and pre-acidification. And look, you know, a lot of brewers are using pre-acidification to try and preserve some of the foam. We know if the pH is over 5, then the lactic acid bacteria can really attack some of those foam stabilizing proteins. And also dropping the pH initially, I guess, gives your desired bacteria the best chance to compete in case there's any other microorganisms that could be present as well. So it's also like a safety from contamination step. Many brewers are using acidulated malt, maybe at 5%, to get the pH down to around 4.5.
Yeah, exactly. And also I saw a question about CO2 blanket. So together with the pH, it's also a way to choose and promote certain microbes rather than other ones, because with the CO2 blanket there's no oxygen, so you avoid some bad spoilage microbes to get in, such as Acetobacter, for instance. And by also choosing a pH, by also choosing the right amount of hop, by also choosing the right temperature range, you are actually able to really promote one microbes on top of the others. But more specifically, if using Cefsar LP652, you're also adding a lot of cells at one point in your wort, and because of that, it's also a way to thanks to the pitching rate that you have. By adding only 10 grams per hectoliters, you're already adding 10 million cells per milliliters. So doing so, you already make sure that you have kind of a quick and a big development, big inoculation in your wort.
Yeah, thank you, Simon. We had a question from Patrick Brown about the wort makeup affecting pH. You may have answered some of that already, Simon, when you were going through our kettle souring trial. We see that the density of the wort, the higher the density, the more that buffering capacity you have, so you'll get less acidification with high density. But also in general, the wort makeup, you know, are you adding any other minerals, and what's the specific malt bill there? All can have their own influence on the starting pH as well, which will then affect your final pH. Just a note too, the lowest I've heard of somebody, and there's probably other people tried some experiments, we'd like to hear about them, but I think it was 2.8 was the lowest I heard that someone had pitched the Cefsar lactobacillus and it got down to. So obviously stayed alive that long. But that's a
yeah, it does. In our studies, we reached 3.2, but yeah, depending on the malt bill, depending of course of the pH that you have at the beginning, you might also influence and lower a little bit this final pH that you can get with the LP652.
Yeah, thanks, Simon. We had a question from Ollie Bird. From Good Georgia, New Zealand. Hi, Ollie. We've always found the souring in kettle takes more than 24 hours, more like 48, even observing the recommended pitch rates. Any ideas? I'm not sure. I don't think he's talking about our strain in particular. So 40 degrees without any hops. So it's very good. The temperature sounds good, 40 degrees. Like we know our strain, but I'm not sure about all the other strains and the exact right temperature for them. One thing could be density, Ollie. So we know if you're brewing at a higher density, it will take longer. But it might be a strain specific thing. So, you know, each company who's selling Plantarum is the most successful for kettle souring commercially, because it does produce acid very quickly, and it is a little less vulnerable to some of the other lactobacillus strains to temperature shifting. But yeah, I'm not sure what's going on there. It could be a density thing, it could be a strain thing, and yeah, maybe
could be also the temperature, because from our experimentations we saw that actually the range is of course 30 to 40 degrees Celsius. But if you remember, lactic acid production at 40 degrees was lower than the one at 37 degrees. And we also studied the different cells count that you get with different temperatures. And actually, if you want to have the best temperature for the Lactobacillus plantarum and the best development, inoculation, and therefore the best lactic acid production, this is 37 degrees Celsius, because at 40 you already start inhibiting a little bit, slightly, the lactic acid production. So I believe using 37 or slightly lower temperature would also help on the kinetics of the fermentation.
Yeah, thank you. That's good. Sam Williamson, kettle sours and dry hopping, how do we get the hops to pop? I guess it's adding the right ones enough and late enough. But Simon, have you got some comments on how do we get the dry hops to pop when you're competing against, I guess, Sam, you're talking about, you know, you've got a lot else going on with the sour beer. How do we actually still get the hops to shine through?
That's a tricky question, because this is a sour beer. The traditional sour beers are not meant to be very hoppy per definition. But I believe you would just do the traditional way of dry hopping. There's no particular way, because of the fact that it's a sour beer. Just pay attention to not use hops in your boil, in your first boil, before lactic acid fermentation. But then in the later stage of your brewing process, you can definitely use regular dry hopping and find yourself the right amount and the right expression that you want to balance the acidity of your sour beer.
Thanks, Simon. Yeah, I mean, look, we love to get feedback on from brewers on this, because you're the magicians and the creators, and we don't get a chance to test everything, and that's why we love your feedback. I think if I was talking about kettle sour and dry hopping, I have tasted some delightful dry hopped sours that have, I guess it's about pairing the hop, the main aromas you're getting from that particular hop with the sour character. So you're looking for citrusy flavors in your hop that might complement really well. I think if you're going for the more creamy, sometimes you get a contrast and it doesn't work so well. Yeah, it's all about that combination of the two, the hop aromas with the sour and the taste of the sourness. Is it sort of a bright lemon or something else? So, okay, we've got a few other questions. What caused a lime beer that was not quite as sour as expected? So it sounds like maybe the acidification from the bacteria did not go to plan. And look, there's a few things that can cause that. It could be a temperature issue. So maybe the temperature was not held at, you know, the ideal temperature for the organism. Maybe the density was a little bit high and it prevented the acidification. Maybe there was, you know, too many hops in there for that organism to really drop that pH. Might have inhibited it. There could have been a contamination and competing microbes in there. I guess the fruit itself adds acidity, so you've really got to do some quite specific calculations on the acidity that you're adding from the fruit itself. And then if the sugars in the fruit will then be fermented as well, and what change that will make on the final beer. So there's a lot of trial and error and playing around and tasting to try and get it. Yeah. Okay, so we've got a question from Lewis Kerr. Apart from yeast autolysis and acetic acid production, what risks exist to the quality of the beer if exposed to extended barrel aging, e.g. 2+ years? Are all quality and flavour benefits of aging achieved in a shorter time period under 1 year, or do they continue to develop? That's a really good question. And I think from our side, from my personal side, I've heard a brewer, actually a very well-known brewer from Australia, speaking about having 2 summers in barrel is really good. So the temperature fluctuations obviously make the wood contract and expand, and then can speed up the aging process a little bit. And for the mellowing and melding together of the flavors over time, and to get the right amount of contact with the barrel as well, that brewer said, you know, at least 2 summers, so 1.5+ years, I guess, on that. Simon, from a technical point of view, quality and flavor benefits of aging for more than 1 year or less than 1 year. Got any comments?
So if we are talking about the fermentation, then there is definitely an advantage and a nice complexity of flavors that you can bring through the aging in barrel, because you would have different microorganisms starting to ferment, as we saw, for example, on the lambic production process. But also in the barrels, you would have some wild bacteria, some wild yeast, being able to start to keep going on the fermentation and more develop specific flavors. If you look at Pediococcus, for instance, they are tolerant to pH and alcohol, so they would start producing lactic acid, but also diacetyl. Diacetyl is enough flavors, of course. But then, if you have also Brettanomyces in this barrel, then the Brettanomyces would be able to convert this diacetyl into other flavors, and so it is an advantage in this case. But then, if you look at oxidation, depending on your beer, if you have dry hopping in this, then of course the oxidation might not be very good for the beer. So it all depends on what you want to do and on the microorganism you're using. And that's a very complex process, and it's not always easy to say, okay, this is the kind of beer you get, or this is the kind of flavor you get.
Yeah. Great, thanks, Simon. We've had a few questions. We often get asked, you know, what's the density drop you get just from the souring? And also further, we had a question from Lewis Kerr, do bacteria create residual heat as a byproduct of consuming sugars? Do you want to speak to a little bit about the Plato drop and temperature there, Simon?
Yeah, sure. So for the Plato drop, this is something, I didn't talk about it during the presentation, but basically, because the Lactobacillus plantarum will be consuming glucose and fructose, so the very simple sugars, and the drop in Plato at the end of the Kettle Sour process, so after 48 hours max, would be between 0.5 to 0.7 degree Plato.
Awesome. So you see, from what I understand from brewers, there is some heat, but it's not the same as an alcoholic fermentation where you've got a much more energy exchange going on, with the Saccharomyces fermentation, for example.
And we've noticed that because in your kettle you don't necessarily have temperature control. When you do a kettle sour process, you can have temperature for the start of the fermentation. But if you let it drop slightly over 2 days, we notice that you still have a very fine fermentation and a very fine lactic acid production.
Great. Okay, I've got a question. I don't think we've covered this one from Garth Ridgway. He's interested to understand how the experts recommend dealing with a mixed sac and lacto culture. Can I build this starter up? Can I harvest and repitch? How to maintain that appropriate percentage of sac and lacto? It's a really interesting one. With our Cefsar, it's designed and selected for kettle souring. You then boil after it's gone. But if you're adding it afterwards, I guess the thing to keep in mind with mixed cultures is there's a specific ratio of the organisms, and when you repitch and use again, that ratio can change. And sometimes over time, there's a lot of anecdotes from brewers where the bacteria start to then take over a little bit. So lactic acid bacteria, they're quite prone to contamination if you're keeping them because they don't like hops. So, and hops are antimicrobial. Also alcohol, there's still some sugars there. You need to keep the oxygen out. So it can be done, but it's probably a few things to be very careful of when you're doing that. Yeah, so the first pitch, you'll have your correct ratios, and it's just about really careful handling ongoing, I think. And it's a trial and error process. Anything to add on that one, Simon?
No, no, good.
Okay. And if anybody who hasn't already discovered, there's a lot of good resources out there if you're just getting into sour beer. You know, there's quite a few websites like Milk the Funk, Embrace the Funk, the Sour Beer blog with Dr. Lambic. There's also quite a good Sour Hour podcast, which is quite good too. So, yeah, lots of resources out there. And look, we're really happy to try and answer your questions as well. I'm trying to think of some other questions we get on off notes and things like that. We did mention earlier butyric acid. That's quite a common one that can happen with the sour mash from the Clostridium, which is naturally present on the grains. And it can operate even if you've limited the oxygen. So, you know, CO2 purging and CO2 blankets are a really good idea. You'll limit things like acetobacter, but that Clostridium can still grow. And it can produce butyric acid. Some of those can then later be converted by something like a Brettanomyces, but not always. And sometimes that butyric acid level is just really high and it smells a little bit like a vomit or old shit. So not so good.
Interesting.
Yeah, and we've talked a little bit tonight about, or the morning, actually, some of you it's morning, isn't it, or early afternoon. We've talked about buffering capacities of wort, and, you know, the higher the density, the more buffering capacity there is. If you're doing souring in a mash, the buffering capacity is even higher because you've got actually all that grain material there. So that also has a bit of an impact, and it can take a little bit longer for the souring to happen because of that. May not be a bad thing. Got some more questions coming through. Some good tips coming on the dry hopping. That's good to see.
Mm-hmm.
Yeah, and Alistair, I can see you've got a bunch of notes around long barrel aged beers. You're certainly some really nice vintage aging, and it's all about tasting and blending. If you know suddenly a batch goes wrong over time and you suddenly have vinegar, then that could be a shame. But some beautiful beers have a really long barrel aging process. You know, some microbes can even start to actually ferment some of the wood material itself as well, and actually metabolize some of the cellulose and some of the wood. So that would probably be only relevant for the really long barrel age ones. Just looking at some of the frequently asked questions we get to see if they're useful for anybody. Question from the start: can lactic acid bacteria transform citric into lactic acid? Simon, do you have any comments on that one?
The lactobacillus transformed glucose and fructose into lactic acid, and I've never heard of any transformation of other acid into lactic acid.
Yeah, no, neither. We talked about pre-acidification techniques earlier as well. Sometimes we get asked what technique's better than the other, and there's no right answer to that. It's what you like and what I guess you've got available to you to do as well.
Yeah, with your equipment.
Fast and clean, you're going for really complex. You know, kettle souring is considered very safe, of course, as far as contamination goes. It's probably like a good first step if you're getting into souring. I'd probably recommend that. Why did we use Plantarum for Cefsar? I think we've covered that already too. It's quite fast and clean.
Yeah, we did a screening of a lot of different lactobacillus strain, and what we wanted is to have good kinetic, good fermentation during the Kettle Sour process, because this is a very critical point where you don't want to have any other microbes to be able to develop instead of your lactobacillus strain, and also for the flavors that it was able to develop on the fruity notes, tropical citrus notes. which we found goes very well with the lactic acid production and the sourness that you get. That was the best balance that we had from the different tasting with a lot of lactobacillus strains.
Yeah. Awesome. Well, thanks everybody. I think that probably comes to the end of our Q&A. We've really appreciated you all being here with us. We'll try and keep going with some webinars. It's a shame we can't all physically see you. We love to be out in the market and talking to people. But we'll be holding more webinars and also Fermentis Academy events where you can continue learning. And yeah, anything we didn't get to today, please make contact through your distributor. Many of them are on the line right now, or through the apac@fermentis email address. And very soon we'll send you out these slides. And please download the app.
Yes, if you're interested in knowing more about the studies, the different studies that we are doing on our yeast, or R&D and or panel of tasters is doing a lot of work for you guys as a brewer, because we study a lot of different conditions with our yeast, different pitching, different temperatures, lots of different conditions, and then we study the kinetics that you get from those fermentation, but also the flavor profile. And it's actually a very interesting tool for you if you want to know more through our app. If you go in the make your choice part, you can actually select different studies on our yeast and know more about the exact condition that will bring you to the flavor and the kinetic you like for your strain.
Cool. Thanks for that reminder, Simon. Thanks, everybody. Have a great
Thanks
evening.
a lot.
I'm going to go and have a taste of a new sour beer I've just received, so I'm quite excited.
I'm going to go and have a breakfast. I wish I could have a beer that early.
Thanks for getting up for us, Simon. Bye,
Thanks
guys.
a lot, Bye.